Hey everyone, I'm really happy to be here. It's my first time back in Berlin after like 3 years when I moved away from here. So yeah, and excited to talk today about the staking economy and proof of stake. So just a bit about myself. So I've been in crypto since 2013. I actually got into crypto right when I moved to Berlin, and I started the Bitcoin meetup here in 2013. And then I was at Tendermint in 2017, so I was COO at Tendermint. So Tendermint was the company that started kind of the Cosmos ecosystem and was one of the first modern proof of stake network. So I was there kind of at the inception of proof of stake. And it was already very clear that the future was proof of stake. Ethereum was working on proof of stake. Polkadot, all these other networks were also already working on proof of stake. So I wanted to start a company focusing on infrastructure for proof of stake. So I started that around 6.5 years ago. Yeah, I mean, aside from Course One, I'm also at the Interchain Foundation. So that's the Cosmos Foundation on the board there, and have been running the Epicenter, so which is at this point the oldest crypto podcast. So proof of stake. So proof of stake is basically a mechanism that is used to achieve agreement in a network about what is the valid state of the network, and to validate all the transactions and make sure that transactions are processed and the chain is secure. And for that you rely on validators who have this role of proposing and validating new blocks. And I was wondering, is it possible to move this timer somewhere else? So turn it, because it's hard to actually, thank you. And then, the validators are basically chosen based on how much assets they have locked as collateral. And of course, that gives this level of economic security. So just a little bit maybe about Course One, a few things. So as I mentioned, we started around 6.5 years ago. And today we secure around 50 different blockchains and have around $3.5 billion staked with us. And we around 65 or 70 people, and primarily focus on staking, but there are a few other things. So we also do a lot of venture investing in kind of new projects coming up. We have a big research focus, so we publish a lot of research. A lot of it is around new protocols, but also around research related to proof of stake and kind of like the new things that are coming up there. And we've put a lot of work into Opus, which is our Ethereum staking product. So I just want to zoom out a little bit and talk a bit about proof of work versus proof of stake. So if we look today, right, then if you look at the entire crypto market cap, it still basically does about half of the crypto market cap is proof of work, but that's basically all Bitcoin. And then the rest of the crypto market cap is practically all proof of stake or assets that are actually issued on proof of stake chains. So if you look at the top 10, something like 8 of them are proof of stake assets. And then there are things like USDT, USDC, which today also primarily are issued on proof of stake chains. So we already have that basically proof of stake really secure almost the entire crypto market cap outside of Bitcoin. And of course, even roll-ups and stuff like that, well, indirectly, they're still, since they're relying on the security of the underlying proof of stake network, at least once they have fraud proofs and all of that stuff, still reliant basically on proof of stake. So it's really become this fundamental thing of how we secure blockchains. And why is that? There's different reasons, right? But definitely one of the big reasons is that there's this huge efficiency advantage. Right, so Bitcoin pays around 11 billion to miners every year. And in proof of stake, the entire proof of stake rewards every year are around 13 billion. So on the surface, it looks like, wow, that's actually more, right, than for proof of work. But it's kind of deceptive, right? Because in Bitcoin, all of the rewards and all of the mining rewards, they go to the miners, and the miners spend it on hardware, and they spend it on electricity. But in proof of stake, it's different, right? Most of the rewards, they go back to the token holders who already hold that asset. So it's not really a cost to the token holders. And the cost is really just what is paid in commission to the validators. And let's say we take something like 5% on average, that means all of the proof of stake networks together maybe spend something like $600 million a year, for operating all this infrastructure. And so if you just take this efficiency comparison here, it means basically in terms of, how much is being paid to secure an equivalent amount of economic value, then proof of stake is around 8.5 times more efficient than proof of work. This was actually twice as much just very recently before the Bitcoin halving. But yeah, in addition to that, right, maybe a different point, you can argue that the security of proof of stake, you can also think about, what has the higher level of security. I think from a game theoretic perspective, it's also the case that proof of stake has, it's more expensive, more difficult to attack a proof of stake network. Now, in terms of, the type of customers that engage in proof of stake, it's actually a huge range. Again, there's a big difference from proof of work. Proof of work, it's a bunch of miners, which is its own secluded industry. But in proof of stake, because it allows any token holders to engage with it, we really have a huge range of different entities that engage with staking. So that's individual, retail investors, it's foundations, it's the core teams, and it's all kinds of different institutions as well. And now, if you look a little bit at this staking economy, we dive a little bit in here. So, the total staked value today is around 260 billion. And out of that, around 18%, 19% is being staked through liquid staking protocols. So liquid staking protocols, basically, they allow you to, pool the asset, and then it gets staked from that smart contract. That's especially popular on Ethereum. And it's not super big on other chains. And now if you look at the staking rewards, like how do the staking rewards break down? The vast majority of rewards, they come from coins that are new coins that are being issued with every block. So that's, almost 3/4 of it. But, there are some other things, that we have gas fees, basically when people pay transaction fees, and MEV. Now, the gas fees and MEV are also very Ethereum heavy, right? Like most of the other chains, they have pretty minimal, still very small economic activity. And so it's really inflation on most of the chains. But there are some exception here. For example, if you look at this 100 million mark here and other, I think a lot of that is DYDX. And in DYDX, it's basically on-chain decentralized exchange, and the trading fees, they get paid to the people staking. So, and this is around 100 million a year. So it's actually very impressive that you have a chain that's entirely secured through the fees that people pay from using the chain, and they don't have any inflation on the DYDX chain. So there definitely are some other protocols, and I think in the future, of course, we would expect this pie chart to change a lot, right? I think the inflation bit is going to go down, and it's going to go down hopefully because these other things go up, but also because the protocols generally have some kind of schedule where inflation decreases, as time goes on. Now, when you look at like proof of stake, you also see there's a lot of different proof of stake designs. And probably the biggest sort of two categories of proof of stake design is, Ethereum on the one hand, and on Ethereum we basically, we don't have in-protocol delegation, right? And basically each validator has the 32 ETH, and there can be unlimited number of validators. So that's kind of the Ethereum design. But most of the blockchains, they have a different design, right? Most of the blockchains have in-protocol delegations, and they have a limited validator set. So I think sort of the paramount example here is like Cosmos, for example. So let's say you have a maximum of 100 or 200 validators. It's something that each chain can decide. And then anyone can create a validator, and the ones that actually do the work, the ones that are actually active, are the ones you basically list all of them by how much they have staked with them, and then the 100 largest ones, for example, are in the active set. And then, maybe one of them has like 5% of the voting power, and another one has like 0.1% of the voting power, and then the one has 5%, will produce 50 times as many blocks. So this is like really easy, really convenient, it works really well. And this is something that basically most of the chains have adopted a model like that. So that's, Solana, Aptos, Sui, Cosmos, but there will be many others that can be named here. And then there's a few that have chosen sort of an Ethereum model, and then there are others that have some kind of a hybrid in between. In general, I think it's a good question of like, did the Ethereum staking design make sense? I don't, it's a questionable thing, I would say. It definitely has created a huge amount of need to create like other things on top, like smart contract systems and stuff like that. And yeah, so in terms of the different products, right, that people need to sort of for their staking, it also varies a lot, right? So we have the delegation thing, which is sort of the standard thing that I just mentioned, right? You just make a transaction, you stake with the validator. Generally, all the logic is handled on-chain. So the rewards are distributed on-chain. The validator can set the commission rate. It automatically gets deducted on-chain, and it works really well. It's not always like that. Some of them have, for example, that rewards aren't managed on-chain, like Tezos, or there are some exceptions. But generally, it works like that, and it works pretty well. But there's some other types of products. So, for example, we do like white label validators where there will be some party, they want to run a validator with their own brand, their own maybe commission rates and stuff like that. And then we can kind of run the infrastructure for them. But it's sort of, it's kind of like a validator as a service type product. And then, we have liquid staking. Liquid staking is also something, again, it's primarily something that has traction today on Ethereum. And I think it has traction primarily on Ethereum for that previous reasons, that there's no in-protocol delegation, and there's basically a bunch of constraints that Ethereum has imposed that make the sort of normal staking experience pretty inconvenient. And that's why I think liquid staking has a lot of traction there, but it's also something that's gaining traction in other networks. And it's also something that, we, for example, do today for customers using, for example, a protocol called Stakewise, which is very elegant. And then, of course, you have other things like API products that easily allow customers to integrate staking offerings into their product. So, that can be like wallets or custodial products or like exchanges, things like that, where they have customers who are holding asset on their chain and they want to offer staking to them, and they want to outsource kind of the work of actually running the infrastructure to a third party. Yeah, so this is kind of the liquid staking thing, right? Sort of as I mentioned, right? You can see here on the left side, basically Ethereum, where there's a lot of liquid staking, and on Solana on the right side, right, where you have only around 5% of the tokens are being liquid staked. Again, I think that has a lot to do that the Solana staking experience is really simple and works well, and so the benefit for liquid staking is more limited. The benefit for liquid staking on something like Solana is really like, hey, I want to use the token, I want to stake it and use it in DeFi too. And some people want to do that, but it's not actually, the primary thing that people want to do. Generally, they just want to stake and forget about it and earn their rewards. Yeah, but still, it's also something where, we have, for example, an offering. This is pretty interesting, right? Because in the beginning, like Lido was really the dominant liquid staking offering. But now there's a lot more flexibility. There's a lot more products coming up. So, for example, there's also an offering we have now where you can stake with Course 1, but you can also liquid stake at the same time. So I'm going to talk a little bit about MEV. So MEV is an area that had a lot of attention in the last few years. I would say at the moment it's maybe a little overshadowed by some other areas, but it's basically has to do with when a validator creates a block, they have some influence on what transaction goes into the block, and that way you can basically generate additional revenues. And the company Flashbot, right, they built the software to create an auction so that the rights to the block can be sold off to third parties and they can bid on it. And so this was kind of a controversial area, but of course in the end it is something where you have to assume that the people running the protocols are sort of going to do the profit maximizing thing, and then people designing the protocols sort of have to design an incentive that the thing works, even if people do that. So Ethereum has gotten very complicated too in terms of how blocks actually get produced. It's quite different from other chains. On other chains, it's basically like, we as the validator, we get the transaction, order the transactions, create a block, and that's kind of it. But on Ethereum, we've sort of taken this apart into different roles. So the proposer would be like us as the validator, but then we also have like a relayer, and then we have a block builder. And the block builder is basically the one who actually creates the block. So the transactions get sent to the block builder, they create a block, and they say, oh, this is how much this block is worth. The relayers send it around, and then the proposers kind of choose the one that pays the most and like broadcast that. So that's kind of the way Ethereum has sort of played out. And the MEV kind of also derives from optimizing processes around that and doing this in a sort of more efficient way. And this is something we've focused quite a lot on. And we've kind of ended up building a sort of proprietary Ethereum version that does this in a more efficient way. So we measure a lot of data about the network and optimize different parameters, and then are able to generate, higher MEV rewards. So I think over the history of running this, we've been doing it for a while now, something like 9% additional staking rewards or MEV rewards on Ethereum. So yeah, we also published a bunch of like stuff on this, including sort of like an academic paper on the research behind it of how this works. So I don't have a lot of time, but I do want to talk a little bit about restaking. So restaking, basically, the high-level idea here is that when you're staking money, it's sort of locked up. And some of it is at risk, but some of it could be slashed if the node operator, the validator, misbehaves, and that kind of secures the protocol. But most of it is just there, and the slashing risks in reality are very low. Right? Like we've never been slashed, and so we've never lost any money for anyone this way. And this is not untypical, right? In general, the amount of money that has been slashed has been really low. So of course, it's a good question to say, hey, we have all of this economic value that's being locked up here. Can we reuse this to do something else at the same time, earn additional rewards? So that's basically the high-level idea of restaking. Now, this idea has kind of existed for a while. We have this kind of thing running on Cosmos. There is something called interchain security that basically is already restaking. And of course, at the moment, probably the most hyped project in Ethereum is a project called Eigenlayer that's trying to do this for Ethereum staking. So as a staker, you can either do liquid staking or you could directly stake, and then you put you sort of restake your ETH, and then there will be basically different blockchains or different services called AVS that are then secured by this staked ETH, and where the user or the staker can earn additional rewards. So this is like I would say one of the biggest areas of activity at the moment. I think on a high level, this category makes a lot of sense, right? It makes a lot of sense to say, hey, I want to earn additional rewards on all this capital that's being locked up there. But I think when it comes to, the actual implementation of it, it's super early, and a lot of things are not figured out, and probably a lot of the designs that have been made maybe don't make that much sense. So I think it's going to take us years to actually figure out of how all of this works, and it's going to mean a tremendous amount of change and evolution, especially around Ethereum staking, I think, in the next years. And it's brought a lot of complexity to Ethereum staking. It's going to bring a lot of new products, new types of offerings that people are going to build. Let's see. Layer 2s, I think I'm going to skip this. Yeah, maybe just a final thing to briefly mention. In some networks, it's not for all networks, but in some networks, validators actually also play a crucial role in on-chain governance. Right? So basically, it means that someone can make a proposal, and then the validators can vote on the proposal, and that's kind of how the network can make decisions in a decentralized way. This is especially the case for, and there's different types of decisions. It can be a software upgrade. It can be there's a community pool and deciding how to spend the money. It can be just some text proposal about, I don't know, what's this chain for, or something like that. It can be parameter changes. So this is especially relevant on Cosmos networks. They basically all do that. Also some of the other networks, but most of the activity we see in Cosmos. And just an example of like the volume of activity here. So last year we voted in 1,246 governance proposals. So it's a huge amount of work too, of like looking at all these proposals, voting on them. But it's really actually amazing the level of sort of decentralized decision making that's already happening today on proof of stake networks, using validators. So I think that's it. Yeah, there's a report on that if you're interested. But yeah, so I don't know if you have time for any questions. Or?
We do, yeah. We have a few minutes. So who wants to start?
All right. Yeah.
Just 1 second, sorry.
Do you see any benefit in staking outside of like validators? So for example, you have a blockchain and you don't have validators there. For example, Optimism, if they decide to have
yeah.
They would, for example, decide to have staking of OP token. Like, do you see any benefit of doing that if they don't have a role for validators to kind of pay rewards to?
Okay, so let me try to answer something that I think is sort of on this topic. I don't know if it's exactly your question, but I mean, sometimes staking gets used for like other things. People put out tokens in some sort of DeFi protocol and stuff, but there's actually no service being run, no protocol being secured. So I'm gonna like ignore this. But I think when it comes to things like Optimism or layer 2s, right? There we basically have the situation that these things generally are very centralized, right? Where you basically have like, one sequencer that, orders all the transactions, processes all the transactions. If they go down, you kind of rely on them. If they get censored or, the government steps in, they could shut the chain down. And I think the thing that we're seeing is that all of these, or most of these roll-ups, they basically see this as a problem, and they have a plan to decentralize this with time. And generally, it goes in some sort of different steps, right? So first, it's just one sequencer. Then they say, okay, we're going to have a set of like, 5 different sequencers or something like that. And, it's a approved list that they work with, a little bit like the Lido set. But then I think many of them do want to go to a mode where it's like an open and permissionless system. And I think that's when you actually, what is this going to look like? It's probably actually going to start looking a lot like proof of stake systems again, where you say, okay, someone has to lock up a bunch of tokens to guarantee that they're not going to do something malicious. And if they do something malicious, then they're going to be slashed. And you need some sort of consensus between the different sequencers to say, like, who's the one that's like sequencing right now and who comes afterwards. So I think our expectation, I would say, has been for a while that actually a lot of the roll-up space is going to kind of evolve in the direction to look more like proof of stake networks, and that we're going to have a lot of this kind of staking infrastructure function there as well. And it's not just there, right? I think we have that kind of role in other types of protocols too. I mean, for example, we run also interoperability protocols like Wormhole or Chainlink oracles, and Chainlink's introducing staking as well, where they basically, again, want people to like, lock up tokens, and they run the oracles, and if they do something wrong, they can be slashed. So I think that's kind of like a general paradigm that can be used for, any kind of infrastructure operators to guarantee that they do it right, and to allow a sort of open system where anyone can come in. Yeah.
Sorry, we don't have much time.
Maybe just
quick
question.
one. Okay. Just wait a second.
Yes, interesting numbers. Do you have an opinion about solo staking? How can they compete?
Yeah, I mean, it depends, right? Of course, it's easy to, anyone can kind of like run a solo staker, right? And then I guess the question is like, how convenient is it? In terms of returns, I think, your returns might be a little bit lower, but I think your cost is definitely higher, right? So your cost is going to be higher, plus you have the sort of additional work around it. And I think what is also the case is with restaking, it is the case that it's actually becoming harder, I think, for solo stakers to compete, you know, because now if you say, okay, you want to restake and you want to run a bunch of different AVSs, all of a sudden it's like now you have to run a whole bunch of chains. Or if you don't do it, then you will just make lower rewards. So I think it's definitely the case that I think solo staking is probably going to continue to be, you know, harder and less profitable with time. But I think it's going to continue to be an option, at least on Ethereum, right? Because I think they designed also the entire proof-of-stake system to try to make it easy to do solo staking. Now, was that a right call? I don't know, because I think it has a lot of other negative consequences. But I think that capability is going to continue to be there.
Thank you so much. If anyone else has any more questions, I think Brian will be around, so please approach him. And thank you so much, Brian, for your great presentation.
Thank you.